This video will demonstrate how to build a slide dolly for your DSLR or video camera. You might expect to pay upwards of $150 for a commercial slide dolly. The materials for this project would cost about $50. The dolly is made out of two pieces, a track and a shuttle. As you might guess, the shuttle moves back and forth along the track. The track and shuttle are both made from aluminum. The track is 1 inch by 3 inch rectangular tubing with a 1/8 inch thick wall. In this case, the track is 36 inches long, but the track can be made to any length desired. The shuttle is 4 inch wide aluminum association C-channel, cut 6 inches to length. The sides are 2 inches high. The aluminum association channel refers to how the sides are formed. The inside and outside are parallel to each other. It's doubtful that you will find the required raw stock at your local hardware store or home center. You'll need to find a metal supplier in your area or order online. The tools needed are pretty simple. A file, some sandpaper, and a drill. The one exception to this being a set of taps. Taps are used to thread holes in the shuttle and the track. More on that later. When handling the raw stock, be sure to wear gloves. The metal burrs are sharp and can give you a nasty cut. The first step in construction is to make sure the ends of the track and the shuttle are square. It may also be necessary to cut the track to the correct length. Either of these steps can be done using a miter saw with a carbide tipped blade. If you find it necessary to make these cuts, be sure to wear safety glasses. So we're just going to check the square of this end. It's a little bit off, but it's pretty square. Now let's check the length. I'm expecting this to be 36 inches in length. When cutting metal, make sure that you have your safety glasses on. This is a 10-inch carbide tipped blade, and it will cut through aluminum. It's going to be a little bit noisy. Pretty good cut, but we still have burrs on there, so I'm not going to touch the ends until I have my gloves back on. The piece of scrap also has some nasty burrs on it too, so be careful even with the scrap. Don't brush the aluminum chips off with your hand, use a brush for that. The chips are just as sharp as the burrs. So by now you should be paranoid about cutting yourself on the burrs, and there's actually a tool called a deburring tool. I don't have one, but what you can do is use a file and just file off the burrs on the outside and on the inside. Obviously I'm at a strange angle because I'm doing this for the camera, but you get the idea. You want to have this nice and smooth to the touch. No nasty pieces of metal. You can finish it up with a piece of emery cloth or sandpaper. Make sure you wear your gloves, because if there is a burr there, it can still cut you. We've got it deburred. What we want to do is mark out where all the holes are going to be. You can do it with a ruler, but if you want to have some consistency, use a carpenter square. refer to the plans. If you source your own material, you might have to make adjustment to them. For instance, I'm going to be marking holes for the 1-inch feet here. If you use smaller feet, you might want to adjust it. If you use bigger feet, you might want to adjust the holes. So you're going to set your carpenter square. To the correct measurement. Sorry, mine's a little sticky. It's very sticky, and I'm wearing gloves. And now I've got the center point for one of the feet. I'm also going to have 3 holes down the center of the rail, and that's so that I can mount the rail on to a tripod later on. If you look at the finished product, those are 1/4 20 threaded holes, and that's so that I can mount this on 1 or 2, maybe even 3 different tripods depending on where I need to use it. This is 3-inch. Half of 3 inches is 1.5 inches. There's your math lesson for today. But actually, let me just show you this, because if I set it to 1.5 inches, I measure it from both sides. You see I'm not directly on it. I'm just a little bit off. And that can be the thickness of the line on your scale. That can be the thickness of your pencil lead. By the way, you don't need to use a pen on aluminum. Pencil works on it just fine. So we're going to strike a center line right down the bottom, or right through the middle of this. We can also use the carpenter square to measure in. And set that at 2 inches. It's going to be a 1/4 inch hole. And one last hole that I'm going to mark is going to be right in the middle. Of course, the center of 36 inches is, of course, 18. So this is the track, and all my lines are scribed for it. I can set it aside for now. Let's take a look at the shuttle side by side. Let's do a better job of looking at the shuttle side by side. What this knob does is it allows you to lock the shuttle on the slide so that it won't actually move. It also gives you a convenient place to grip it if you want to move it back and forth. There's some 1/8 inch holes, and those are used to hold on the slides. And then there's also a 1/4 20 hole that's right on the top in the middle. That's actually right now what it's doing is it's holding on my quick release. As you can see, what I did is I put 3 in there just so that if you don't need it right on center, or if you need it offset, you've got that flexibility. I'll just put that back there for now. So what I'm going to do is I'm going to scribe up these lines. I'm probably going to turn the camera off while I do it, or actually I'll leave the camera on, and what I'll probably do is speed this up in post. That's my last line. What I'm going to do now is I'm going to use what's called a center punch, which is this tool right here, to make a little divot, and that's so that the blade doesn't wander. The other thing that I could do, if I didn't have a center punch, is I could use a center drill. The way a center drill works is it's so thick that the blade can't wander. They're not that expensive, either is the center punch. Either way will work. I'll do it with the center punch just to show you how you find where you want to drill your hole. You just put it down, you just punch it down, and I don't know if you can see the little divot that it made right there. I'm going to do that to all the holes. Okay, so all my holes are staked. I'm done with this tool. The next thing that I'm going to do is I need to pilot all these holes. Now, some of the holes that I'm going to be using actually need to be 1/8 inch holes. The holes for the feet and the holes for the round slides are both 1/8 inch holes. So I'm just going to pilot everything with an 1/8 inch hole. If you're not familiar with what a pilot hole is, well, a pilot hole is a small hole that you make in preparation for drilling it to a larger size. So what I'm going to do in this case is I'm going to use an 1/8 inch drill bit. I'm just going to drill all these holes out. I'm going to pilot them a little bit differently later on for the holes that get threaded. For right now I'm going to stop the camera and load up my drill press. You could do this with a hand drill if you wanted. I have a drill press. I'm going to be more accurate with it, so that's what I'll use. Once again, if you are going to be working with machinery, don't forget your safety glasses. Just the table a little bit. Remember, at this point I'm just piloting all the holes. Let me stop right there. If you see that that metal there, don't flick it with your hands. Use what's called a chip brush or just any kind of shop brush to get those out of the way. The reason that I say that is that they're sharp and they will cut you and get under your skin. I'll come back and get this hole in a second. Because that's doing this last hole is going to require me to adjust the table on the drill press. I'll do that later. It's difficult to do this one-handed for and film and make sure that my hands are in a way for you to see it in the camera. What I would normally do is I'd probably clamp this down just to make sure that it doesn't move around like you see it doing. Again, use the chip brush to clean this off. One last hole. Well, I've got the camera here. I want to just emphasize something about this C channel. This is Aluminum Association C channel. The Aluminum Association C channel has parallel sides and a fillet. Normally a channel, this is steel, this is an aluminum, but this is also a channel. Notice how the sides aren't parallel, they're at an angle, and then they have the fillet. You don't want that. That's not going to sit right on the track. You need to make sure that you get parallel sides. So when you order the aluminum, make sure that you specify Aluminum Association, or there's another kind called American Architectural Association, which is the same. It's got the parallel sides, but it doesn't have the fillet down here. It's more expensive and you don't have to use it, but you do have to use the Aluminum Association at least. Okay, now that we've got all the pilot holes drilled, what we need to do is thread some of these holes. Threading will allow me to put in a nut or something like this threaded knob. And it turns out that one of the most popular sizes, or I would say the most popular size thread for cameras and DSLRs, video cameras, is something called 1/4 20. What that means is that the bolt is 1/4 inch across, and that there's 20 threads per inch. There's also another size, which we're actually going to use, called 3/8 16, which means it's a 3/8 inch hole with 16 threads per inch. That's usually used for heavier cameras and more professional grade things like a big old movie camera. What you can do, if you don't have a lot of equipment for doing threading, and I don't, by the way, you can always adapt 3/8 inch to 1/4 inch if you wanted to do everything in 3/8, or you could just go 1/4 inch, and that's probably going to work for most applications. I'm going to do a 3/8 inch in this demonstration just as a demonstration, and I'm going to do that in the actual shuttle. So the first thing that you need to know about threading, and by no means am I going to give you a complete threading tutorial, you're going to drill another pilot hole. Now you can't drill a 1/4 inch pilot hole because you're going to be using a 1/4 inch tap and it would just slide through. So the pilot hole has to be a little bit smaller, and you can find charts online, but basically if you're going to do a 1/4 20, you're going to use a 0.201 drill to do that. For 3/8 it's a little bit easier to remember. This is a 3/8 inch tap, and use a 5/16 inch pilot. When you do your tapping, you're going to need some type of tap handle. And what happens is the tap goes inside the handle, clamp it shut, and then you can use two hands to turn it. And the reason that you use two hands isn't that it's necessarily that tough. It's so that you can help keep it straight up and down. You don't want to go in at an angle, or else you'll actually cut your threads at an angle. I found this at a tool store. This is a tapper also, but this is for people that can't figure out what up and down is, and I'm one of those people. And this helps keep you perfectly straight up and down when you're doing your taps. So the next thing to do is start drilling some holes, some pilot holes that are a little bit bigger. Okay, so we're back to the drill press. We've got our safety glasses on. We've got our 1/8 inch pilot hole, so this should be pretty easy to do. We've got our pilot bit for the 1/4 inch tap. And that's the hole we're going to tap for 1/4 inch. These we're going to do as 3/8. So we'll do those later. Bring the table and the drill press up a little bit. And we're going to do the 3 mounting holes for the tripod. Now, even if you do have 3/8 inch threads on your tripods and things like that, I'm still going to recommend that you do the bottom of the track with 1/4 inch. And the reason for that is the wall is only 1/8 inch thick, and you really need something thick to hold the threads. And there's only 16 threads per inch on the 3/8 inch. There's 20 on the 1/4, so you're actually going to be better off doing the 1/4 on this. Once again, you could do this with just a hand drill if you wanted. I like to use the drill press because it makes me more accurate. So next stop is to do some threading. Okay, as I mentioned before, I'm not going to try and do a tutorial on threading. There's probably some people that have done a better job than me, but I will share my experiences with you. You want to have the workpiece so that it doesn't jiggle around. And that's why I'm putting this clamp on there. I'm going to zoom in here just a little bit and maybe give you a better view of the workpiece. Now, when you thread, you want to use oil, and you don't want the tap to get stuck in here, and oil helps it. The other thing is, you could actually break the threads or break the tap, and if that happens, that's going to be pretty much a disaster and ruin the piece for you. So, as I mentioned before, I've got this fancy tapping jig. I'm going to load the tap in there. I'm going to use my chip brush to make sure that it's clean. You always want to get those chips off of there. In fact, you're going to see I'm going to back it out a couple times. It's got these channels in here, and that's actually where the chips are supposed to go. But it also makes a nice place to put the oil. They have actual tapping oil, and if you did this a lot, it'd probably be worth buying. I don't really do a lot of tapping, so I just use regular old 3-in-1 oil. I don't know if you can see through there. I'm just going to start screwing this in. Let's see if I can get right on in there. You can see that the tap is, well, maybe you can't see. Let me do this. You can see that the tap is actually cutting right into the hole that we drilled. The trick for doing this is to be steady, not jerky. Because you don't want to just jerk it around because you could break your tap. And you can see right there the flakes of metal are starting to come up. Actually, that's probably a better shot right there. So what I'm going to do at this point, I'm just going to back it out. You can see all those chips on there. I'm going to get rid of those chips with my brush. Maybe give it a little bit more oil. And then keep going. Okay, at this point I think I have all the threads cut because it's pretty easy to turn with just a finger. So let's see how we did here. We've got our first threads cut. I don't know if I'm going to do it on camera, but we need to thread this hole, thread this hole, thread that hole, also for 1/4 inch. These are going to be threaded for 3/8 inch. So what I have to do is pilot those with the 5/16 inch drill bit, and I'll do that right now. Okay, I've got my drill press set up with my 5/16 inch bit. Because this bit's a little bit bigger, I'm going to add a little oil around the holes. It actually stops the bit from binding up. And let's do some piloting. Get those nasty flakes off of there with a chip brush. And now what I'm going to do is I will go ahead and tap it with a 3/8 inch tap. I'll do that back over here on the bench and move the camera so you can all see it. Back over here at the workbench, I have my 3/8 inch tap in place. Gonna give it some oil. Now this is a little bit stiffer than doing 1/4 inch just because 3/8 is so much larger. As you can see, once again, the metal flakes there that need to be cleaned off. If I can find what I did with my brush, it's right in front of me. You can pull this out as often as you want to clean it. In fact, I suggest that you clean it often. The thing is, make sure that when you put it back in, that you catch the threads that you've already started. You don't want to cut a new second set of threads. Remember, it's good to be steady, not jerk it around. I think I'm through here because it just got really easy. Yeah, that's it. You can see, oh, it came off. You can see I've got it in there. I'll just remove it with the T. Stop for a second. Don't know if you can see it. I'll get a little closer. Those are all the metal chips that I created. Once again, before I do the next hole, I want to get rid of all those metal chips. Again, give it a little bit more oil. I'll do the second hole. About this time I'll quit talking, and hopefully this will either turn into a montage or I'll speed it up. Okay, my holes are tapped. Get rid of any chips on the bottom. And let's make sure I did it right. What I've got here, this is just 3/8 to 1/4 inch adapter. And reach off screen here and grab a screwdriver. Obviously a screwdriver that I used to stir paint or something. And you can see that insert screws right in there. But you can also see that it's not flush. It's standing up proud. So what we can do here, because you don't want your camera to rock, obviously, we can use what's called a countersinking bit. I'll show you what that looks like. Here's two examples of countersinking bits. They're dirt cheap. This one was under 50 cents, I think. This is actually a little bit nicer one, but it's a little bit dull. I don't think it's going to matter in the aluminum though. Okay, so what I want to do is just lightly touch that, countersink it just a little bit, and I'm actually going to do it by hand. Just because I kept saying that you can do this by hand, and because I don't want to move the camera and set up the drill press again. I don't know if you can see the difference, but there's a little bit of a countersink there. Once again, we've got some of that nasty chips. We've got chips in the threads too. Let's see if I can clear those out. Let's see if this doesn't fit a little bit better. There you go, it's a little bit better. I think I'll have to do a little bit more countersinking. I don't know if I'm going to keep the camera on to mess with that. The off chance that my countersinking operations mush the threads a little, I'm going to push this back through there. This is called chasing a thread. In other words, there's already a thread there, I'm just trying to clean it up. So today you've learned about piloting for tapping, or threading, and chasing. That's all after I told you that I wasn't going to do a tutorial about those things. it's probably countersunk enough now that it's going to be flat anyway. You know, we're not going to have this rocking back and forth. So let's set this aside for a second. Let's move some tools out of the way, and let's take a look at the slide for a minute. I couldn't find any decent rubber feet like this at the hardware store. I found rubber feet there, but they weren't as tall as this. And the reason that you want it to be tall is the side of the shuttle actually hangs down beyond the depth of the track. So you need to have this lifted up a little bit so that it doesn't, you know, rub on whatever surface it's on. I could cut this, but that's extra work. And the other thing that I might do in the future is I might drill some holes in here and put some screws through there, some machine screws, so that I lock it on the track so it physically can't come off the track. I'm not going to do it in this video because I haven't tried it out on my own. So what we're going to do next is I'm just going to show you how to put these feet on. So the rubber feet are held on with just what's called a machine screw. That's a coarse threaded screw where it's straight rather than flared like a wood screw. And this actually will cut into the 1/8 inch aluminum holes that we created earlier. They're really not that expensive. You can just buy them at the hardware store for $1 for a pack like that. I'm going to drop the screw in there. Align it to the hole. And screw it into place. What we're going to do at this point, and this is why I'm doing that, not just to demonstrate how you can put the screws into the aluminum, I want to do a trial assembly. So I'm going to need some more of these screws, and I'm going to need some more of these feet. Okay, we've put the last foot onto the slide. Now it's standing on its own. Now what we've got to do is work a little bit on the shuttle. The way the shuttle works is these are furniture slides, and they're meant to slide. And I've got some round ones and some square ones. The square ones are stick-on. The round ones stick on too, but they also have holes in them that I can mount, so that I can mount them with a machine screw. And sometimes these are called acorn nuts. Sometimes they're called a cap nut. And it's just going to sit on there and slide back and forth. It's a little bit stiff right now because this isn't the track that it's used to. And then of course we're going to have the slide stop installed so that we can lock it in place if we need to. Now, if you're doing this as a trial, which is what I'm doing here, I'm not actually ready to put it all together yet. If you're doing a trial, you don't want to peel the backs, because you're only going to peel the back on this and stick it once. So what you're going to want to do is you're going to want to use some tape. Just take a piece of tape, fold it over, stick it into place where you think you're going to put it permanently. Remember, there's a little fillet there, so you're not going to be able to stick it right in the corner unless you went out and bought the architectural. And you'll do that to the 4 sliders on the side, and you'll also tape in your 4 round sliders, and then you'll give it, you'll give it a test, make sure that everything fits right. Now, when you first get these, that double-sided tape on the back there, it's actually pretty mushy. And if your fit is too tight, don't be afraid to just squish it in there to make it fit better. Once you do your trial and you're happy with the way it works and the way it slides, you're going to take everything apart and then you're going to want to paint it. Before you paint it, what you're going to want to do is sand it down. And before I sand it, I'm going to take my insert out. And there's a couple reasons that you want to sand it down. Number one, there could still be some of those nasty burrs and chips that are attached or partially attached that you don't want to run into later. The other thing is, when they make these, it's done through a process called extrusion, where they just crush it into shape. They take a bar of aluminum and by using pressure they just roll it into this shape. When they do that, they use lubricants, and those might still be on here, and your paint's not going to adhere well if you've got chemicals on here. The other thing is you want a nice kind of, not super rough, but a little bit rough and finish to make the paint stick on there. What I like to use is a random orbit sander. I'm kind of new to random orbit sanders. I've only just now had one, and I'm in love with this thing. It works great. It didn't cost that much. I'm not going to give an advertisement of where I got it from, but you can probably guess just by the brand. Harbor Freight. You wouldn't want to use a belt sander. A belt sander would be much too rough on it. Remember, this is aluminum, and you could actually cut into it with a belt sander. You're going to want to use a no rougher than 100 grit sandpaper. I'm probably going to use 150 for this. Yeah, 150 grit sandpaper. Now, for demonstration purposes, I'm going to do this right here. I would probably want to get all my tools out of the way so that I don't cover it with dust. And make sure you take the feet off before you sand it. I want to just show you the difference that this is going to make. This is still very smooth to the touch. I didn't really roughen it up. But paint's going to adhere to that a lot better. Doesn't matter if you cut it yourself or if you have the metal shop cut it for you, you're still going to have saw marks here, and this is getting rid of those saw marks. You can sand the inside. You're probably going to have to do it by hand because you won't be able to get your sander in there. Mostly what you're interested in is getting rid of any burrs that might remain from where you threaded your holes. And actually, you can see I've got some kind of greasy dirt in there. Paint's not going to stick to that. And I'm not going to sand this whole thing down on camera. What I am going to suggest is that when you do I said don't use anything rougher than, actually look at all that dirt I got off of there. Don't use anything rougher than 150. You might even want to go something smoother, finer grain for the slide. This is 220 grit. It will still, these are reusable, by the way. I don't have to throw this out just because I've used it once. The 220 grit's still going to get all the dirt and crud off of here, but hopefully it will make it smoother at the same time. Once again, this is for demonstration purposes. This is very smooth right now. When you do it, you're not going to want to have your feet on there. Now it's nice and prepared to paint. I just used a gloss, so you could use a flat paint. The reason that I used the gloss is I thought it might slide better, and I don't think that the gloss is going to affect, it's not going to reflect light into the scene or anything like that, so I think we're fine with that. So at this point, what you would want to do is disassemble everything, keep all your parts in a bucket somewhere, or a box or a bag, so you don't lose them, sand it all down, and then go ahead and give it a coat of spray paint. We already know what the final product's going to look like, and maybe what I'll do is get a couple shots using it. The only thing that I would say that I could have done better with this, number one, I think I already mentioned about putting some threaded holes in the bottom of this of these walls here so that I could make it so it's impossible to come off the track. And the other thing is it's a little bit noisy if you have to do a fast transition. Obviously I just sanded this down and it hasn't been painted, so that's one thing that's making a lot of noise. But if you're actually using the on-camera microphone, that might be an issue. You'll have to decide that for yourself. And I can't honestly say that the commercial ones are going to be any quieter. They're still going to have something that slides or some type of ball bearing. If you think about the ball bearings on a skateboard, they're noisy. So that's the end of this tutorial. I hope you guys enjoyed it. If you make one of these and you like it, or you make one of these and you think it's junk, or you think you can improve on it some way, drop me a line. If you're interested in finding out where I got the parts, drop me a line. I can let you know where I got the bill of material. I don't know if I want to do it in this video because it might violate some kind of advertising taboos. Okay, if you remember, we drilled and tapped some holes in the bottom of the track, and the reason that we did that was so that we could mount it to a standard tripod, and that's exactly what I've done here. I've got a tripod at one end to keep it steady, and then at the other end I've just got a little monopod there. I could use another tripod, but I had the monopod handy and it doesn't take up much floor space, and that's how you might use this out in the field if you didn't have something to set it on.